Welcome to the commercial envelope requirements of the 2006 International Energy Conservation Code training video brought to you by the U.S. Department of Energy. You now can receive 0.10 CEUs towards IECC renewal certification and or 1.0 AIA CEF learning units. However, in order to obtain AIA LUs, new AIA requirements dictated tests must be taken. At the end of the training video, you will be directed to a website to take the 10-question test, applicable to AIA members only. You must answer 8 of the 10 questions correctly in order to qualify for the 1.0 learning unit. BECP will report the AIA members who pass the test so credit can be awarded. A certificate of completion will also be available at the end of the training video.
Hello, my name is Eric Makela. I'd like to welcome everyone to an overview of the 2006 IECC Commercial Energy Code envelope training. Today we're going to be focused on a few primary goals as we go through this process. One is I'm going to try to provide an overview of the new structure of the envelope provisions of the IECC. The envelope provisions have changed slightly from what's happened in the 2003 code, so we'll point out all the changes as we go along. We're going to be providing an overview of the envelope provisions as in much detail as we can over the next hour. And we'll also compare and contrast between the 2003 International Energy Conservation Code and the 2006 IECC. Just a little bit about our company before we start and my involvement in this whole process. Britt, Makela Group assists states in adopting and implementing energy codes and is currently working in Idaho and also in Nevada to help them get their codes up and running and moving. I also served on the International Codes Council IECC Code Development Committee for the 2004 and 2006 cycles, so was very familiar with the code changes and how this code was put together over the last couple of years. Today we're going to be looking at a few things, and we'll focus on some of the major changes. One is obviously the commercial provisions contained in Chapter 5 of the IECC. That will be the kind of the basis for this discussion. And we'll also briefly discuss some of the ASHRAE 90.1 2004 provisions, because you are allowed to go to 90.1 2004 at any time instead of complying with Chapter 5 of the IECC. There were significant changes to the building envelope tables. For example, 37 tables were in the 2003 IECC. That's been dropped down to 1 table. The 19 climate zones that were covered in the tables were dropped down to 8 climate zones. So we have 1 page instead of a lot of pages in there, and it really streamlined the code and made it a lot easier to use. There's also some new requirements in the code for metal buildings, and metal buildings typically are very thermally inefficient. So there's new insulation requirements as far as R value goes, and also the technique for insulating metal buildings that will be reflected in the 2006 IECC. Another big change is that the buildings are now limited to 40% glass to wall area. This is down from up to 50% glass to wall area in the 2003 International Energy Conservation Code, and it means that any building with any glass area up to 40% will be complying with the same set of requirements, so there will not be any divisions between the 0 to 10, 10 to 20, 25 to 40, and 40 and above increments that were on the 2003 code. If you go over the 40% glass to wall area, there's a few different options available to you. One, you can use a Section 506 approach, which is the building performance approach that's in the IECC, or you can go to use ASHRAE 90.1 2004. I first want to cover the scope and application of the code, and this is the same basically as it was in the 2003, except some of the names have changed and things like that, and some of the standards that we're referencing now have been updated. The first you have to answer the question of, does my project have to comply with the Energy Code? And that's covered in Chapter 1, Scope and Application of the IECC. It really hasn't changed a whole lot. Probably the biggest change that's in Chapter 1 is how conditioned spaces are covered and what is a conditioned space. The 2003 IECC had temperature increments between 55 to 85 degrees, and it was said that if you condition between those temperature ranges, a space was considered conditioned space. In the 2006 code, the definition for conditioned space basically says that any space that has space conditioning equipment is considered conditioned space. And a conditioned space, the only cutoff on that is a building that is conditioned less than 3.4 BTUs per square foot. So and that's considered a low energy use building. So essentially any building with a space conditioning system, either heating or cooling, is going to be considered conditioned space under the 2006 IECC. Once you've decided that your space has to comply or your building has to comply with the code, then you have to comply with the building envelope requirements, the mechanical requirements, and the lighting system requirements. So looking at the flow chart, you have in the envelope requirements, you have a couple of options. You can use either Section 502 of the 2006 IECC, which is Chapter 5, or you can always go to Section 5 of 90.1. And again, if you break the 40% glass to wall area, you either have to go with 90.1 or you can get into a Section 506 approach of the code. From a mechanical standpoint, you again have a couple of options. You can go into Section 503 of the IECC or 90.1 Section 6. And with lighting, you can either use Section 505 of the Chapter 5 of the IECC or 90.1 Section 9. Now, the mechanical provisions and the lighting provisions will be covered in a future webcast, and you will be able to download those off the Building Energy Program's website following the webcast. Once you've determined how you're going to comply with the code, then you go ahead and document compliance with the IECC, and this can either be done using forms or it can be done using ComCheck EZ, and then the forms and the plans are submitted in for plan review and inspection. So in answering your first question, does my project need to comply with the IECC? Again, any conditioned space will have to comply with it from an envelope standpoint. So any building with a space conditioning system in it, again, unless it's less than 3.4 BTUs per hour, will need to comply with the code. From a commercial building standpoint, the code is fairly straightforward, and it's very simple on how to define a commercial building. It's essentially anything that's not 1 and 2 family residential, or R2, R3, or R4, 3 stories or less in height. Now, the 2006 IECC does not specifically reference 1 and 2 family residential, but it is implied in the code. So that is part of the code, and it's just not explicitly referenced in the definition for residential. So from a commercial standpoint, this is going to cover what was covered underneath the 2003 code, including offices, retail, hotel, motel, assisted living with greater than 16 occupants, and essentially any building greater than 3 stories. The 3 stories is an important point because a 4-store condominium building would be considered a commercial building. A 4-store condominium with an additional floor of retail, the REIT is all still considered commercial occupancy. So you really have to pay attention to the number of the floors in the building and the occupancies that are within that building. Once we've decided that your project has to comply and it does fall underneath the commercial realm, then we again have a couple of different options on how to get the building envelope to comply. So we can either comply with Section 502 of the IECC, which again has the 40% cap on glass to wall area, or we can use ASHRAE 90.1, 2004 Section 5, or we can always go with the Section 506 approach, which would cover doing the ability to do trade-offs between high glass buildings, high efficiency HVAC equipment, and efficient types of lighting systems. So you have a few options available to you from an energy code compliance standpoint on how to get through the process. So let's take a look at what actually the building thermal envelope, which is how it's defined in the code right now. We'll take a look at the different pieces of that. And again, this is going to be the envelope between conditioned space and the great outdoors or unconditioned space. And there's been some slight changes as far as this goes. The roof ceiling assembly is considered part of the building thermal envelope, and we'll find that the insulation will either need to be placed on top of the roof deck or on top of a sheetrock ceiling or directly underneath the roof deck. And we'll find out that we cannot use a drop ceiling as part of the building thermal envelope. Wall assembly, this has changed slightly. We used to have a definition of what's called an interior wall, and that was a wall between conditioned space and unconditioned space, like a wall between a conditioned office and an unconditioned warehouse. That definition has been taken out of the code. Now, any wall that surrounds conditioned space is considered an exterior wall, and that will play into how much glass you're going to be able to have in the building. It will actually give you a little bit more window area as we start to do the calculations. We'll talk about that in a few more slides. Vertical fenestration and skylights, the code has changed significantly as far as site-built products and the efficiency requirements on those. Floor assembly, this would be a floor over outside air or a floor over an unconditioned space like an unconditioned parking garage. We'll see there's some differences here as far as how if it's got cavities in it, the insulation will have to be placed in the cavity. If it's considered a mass floor, you'll have to insulate with continuous insulation. Slab edge, the 2003 code required in a lot of cases that you insulated the slab edge for higher glass areas, basically above 10% glass area in a lot of colder climates. And we'll see in the 2006 code, the need to insulate slab edge has gone away except for some really cold extreme climates, except if the slab is considered a heated slab. And then below grade wall. This would be a wall that is 85% below grade, and we'll find that there really is not going to be any insulation requirements in most of the climate zones for below grade wall. So what are my options for complying with the IECC? We've kind of gone over these a few times, but we'll go ahead and repeat them. You can either use Chapter 5 of the IECC, which is Section 502, or you can use Section 506, or you can use ASHRAE 90.1 2004. You can always use Section 506, and you can always use ASHRAE, even if your building falls within the 40% glass to wall area. So those other two are always an option available to you. But you have to go Section 506 or ASHRAE 90.1 if your building falls at 41% essentially of the gross wall area. The major change between the 2003 and the 2006 code is the number of climate zones. We have shrunk from essentially 19 climate zones covering the lower 48 and Alaska and Hawaii to 8 climate zones. And the climate zones are further subdivided, based on the levels of humidity and moisture within the climate zone. So we have on the top, we have the marine climate, and it's reflected in the code, a dry climate and a moist climate, and then the specific climate zones that correspond with those climates. So the hottest climate would be considered climate zone 1, which you can see is typically down in the tip of Florida. Climate zone 2 reflects more of the Gulf state climates. Climate zone 3 is actually a fairly kind of a little more moderate climate, but climate zone 3 also accounts for Las Vegas climate, which can be kind of be actually very hot. So we can kind of move our way up the map. The higher the numbers, typically the colder the climates. And then each climate zone number will correspond with either a marine, dry, or moist. And typically that's going to come into play when we get into the mechanical for economizers, and this also comes into play on some of the building thermal envelope requirements, and also things like the vapor retarder requirement. So again, this is a very significant change. And these climate zones, the identical ones, are used both in the 2006 IECC and also in ASHRAE 90.1 2004. This is a new prescriptive approach table. And again, most of the tables were eliminated out of the Energy Code and replaced by this one table. Down in the left-hand column, down on this column is the building assemblies. Across the top are the climate zones. And based on building assembly type and climate zone, that will dictate the insulation R value requirement, or as far as opaque door goes, the U-factor requirement for each of the different assemblies. And there are multiple types of assemblies represented within each of the category. For example, roofs Your first category for roofs will be insulation entirely above the roof deck. So it doesn't matter what type of assembly you have underneath that. If your insulation is installed on top of the roof deck, then you would follow that category. There are some terms used in the table called CI, and CI, as in right here, is considered continuous insulation. So an R15 continuous insulation would be insulation not broken up by framing members. This is similar to what was in the 2003 IECC, but that normally applied to mass walls where you could install insulation continuously and get credit for that. There are sometimes some requirements that were in metal frame walls in the 2003 IECC that also required insulation between frame walls and also continuous insulation. So it's the same concept carried over into this table. It's just called something different. You also have a section down here with metal buildings that we'll talk about. Metal buildings will have its own separate table that we'll look at after the slide because, again, metal buildings are basically thermally inefficient. So so the insulation levels will typically be a little bit higher, and thermal blocks that were not always required in the IECC 2003 will be always required underneath the 2006. Above grade walls, we'll have a few options on there. Mass walls, again, we'll have a metal building category that we'll have to pay attention to, and that will lead us into a new table. And then we have standard metal framed and wood framed walls that were in the 2003 IECC. We'll have a walls below grade category. And you'll see on walls below grade the NRs that go across, and in most cases, except with your in climate zone 7 and 8, you will not have to insulate a below grade wall. Floors over an unconditioned space, you'll have an option between either a mass floor or a joist frame floor, so there will be frame cavities to put in insulation. And in that case, for mass floors, really the only place to put that insulation is going to be continuous. So the mass floor row will have a CI next to all the insulation R values, and joist framing, they will assume the insulation is going to be placed between framing. So that is the R19s, for example, will be assumed between framing. Slab-on-grade floors. Slab-on-grade floors will always, typically you will not have to insulate those, except up in climate zone 8. So the NR for unheated slabs means no insulation, but if you are heating your slab, even in the hottest climate zone 1, you will need to insulate anywhere from an R7.5 up to an R10 for any kind of heated slab. And then last but not least, a new category that was not in the 2003 is opaque doors. And with opaque doors, you will find you can put as many opaque doors in your building as you want to. It doesn't count toward your glass total. But in some categories, they are going to have to be fairly efficient, typically in colder climate zones. For swinging doors, for example, the U-factor requirement will be 0.7, and roll-up doors, like you would find in a service bay and that type of thing, in the colder climates, the U-factor of those will be a 0.50, which will basically indicate some kind of an insulated door. For metal building assembly descriptions, again, this is brand new under the code, and this really reflects this in ASHRAE 90.1 2004. In certain climates for metal building assemblies, you will have to add more insulation than you ordinarily would have to underneath the 2003. For example, on the roofs, it says R19 plus R10. And then basically what the R19 plus R10 means is that you install insulation perpendicular to the roof framing, and then you install the R10 parallel to the roof frame, and the R19 insulation supports the R10. Well, we'll talk about that a little bit later. Higher roof insulation values are going to be required in climate zone 1, 7, and 8. So again, these are either the hottest climate or the coldest climates within the code. In some areas, you can get by with R19 insulation. The one thing I do want to point out on this is that thermal blocks will always be required, it doesn't matter what type of roof system, using a prescriptive approach. In Chapter 5 of the IECC, you will always have to install a thermal block. For walls, again, in some climate zones, you will have to install double layers of insulation. The one layer of insulation, the R13 plus the R13, one layer of insulation actually creates a thermal barrier between the roof, the wall skin, and the metal framing, and the other layer of R13 will provide the thermal insulation needed to keep the building fairly efficient. This is going to occur in marine zones 4 through climate zone 8. So now let's kind of take a look at each one of these separately. From a roof R value requirement, you always have the option of installing insulation entirely above the roof deck. So that's, and that will be not broken up by framing numbers. So you can always do that and comply with the code regardless of the structure below it. We looked at the metal building category on the last slide, and we will talk about that a little bit more and give you an example of how to meet that requirement. Typically, in some climates, you'll have to put in an R19. In other climates, will be 2 layers of insulation, but always will you have to put in the thermal block between the roof deck and the metal framing. And then the typical attic, like you'd see in a residential application, is probably the most straightforward compliance. And in that case, we'll just have to blow the insulation up in the attic and comply with the code. One of the changes that were put into the 2006 IECC was the realization that even continuous insulation on top of the roof deck is not a continuous thickness. And there is recognition in the code that you can vary the thickness less than or equal to 1 inch if you do a weighted average calculation. And this will actually account for the installation of roof drains, which you need in a flat ceiling or a built-up roof system. So there is that allowance within the IECC to account for varying thicknesses of continuous insulation. And again, the CI on here, like on the tables, counts toward continuous insulation. The other recognition that was actually implied in the 2003 IECC but wasn't explicitly called out was the fact that you cannot insulate on top of a drop ceiling and count it toward code compliance. The problem with insulating on top of a drop ceiling is it's very difficult to seal that drop ceiling because your insulation has to be at your air barrier. So to count the drop ceiling as an air barrier, you would have to seal every joint within the drop ceiling, including the recessed lights and things like that that went up in that. So again, this was implied in the 2003 IECC, but it's firmly stated in the 2006 IECC. So if you want to insulate the roof assembly, the insulation will have to be placed up underneath the roof deck or in another place, but again, it cannot be placed on the drop ceiling. From a metal building standpoint, this again was a major change, and it's actually a change for the good. The first change is that R5 thermal blocks are required on all metal buildings, regardless of the amount of glazing on the building and where it's located. In the 2003 IECC, typically this was an option in the prescriptive approach, but on the prescriptive approach for Chapter 5, it's something you have to do. But it is, so it's always required, and then at climate zones 1, 7, and 8, that does require 2 layers of insulation and R19 plus the R10. So in order to build this roof system, the R19 has to be draped perpendicularly to the purlins, which is the way insulation is typically installed in a lot of metal buildings, and then the R19 runs parallel to the purlins, and it's actually supported by the R10 insulation. So from this standpoint, you get a double layer of insulation. You have a thermal block to reduce any thermal bypasses in the purlin, between the purlin and the roof system, and you have a much higher R value insulated roof ceiling assembly. If you have a standard vented attic, and you might see this in a small office building, and it kind of looks like it looks more like a residence than anything else, you'll just go ahead and blow the insulation or put in fiberglass bats, and R30 insulation will be required in most climate zones. But in colder climate zones like climate zone 7 and climate zone 8, an R38 will be required, and there's no requirements for a special truss system, so any truss system would work on that. Okay, so that covers our roofs, and now let's take a look at walls. And the requirements have changed a little bit on the walls in the fact that they define some of the wall systems differently than what we're used to in the 2003 IECC. For example, mass walls are now defined based on a weight per square foot. So in this case, 35 pounds per square foot of wall surface area or 25 pounds per square foot of wall surface area if the material weight is less than or equal to 120 pounds per cubic feet. So things that would fall underneath this category are still concrete masonry unit wall systems and tilted concrete wall systems. That would still fall underneath this particular category for mass walls. Also with mass walls, and we'll see that the insulation requirements really require you to install continuous insulation for your mass wall systems. And you have a couple of different options on there. For example, on Climate Zone 3 and Climate Zone 4, you can actually use integral insulation instead of the continuous insulation installed on the exterior of the mass wall. So what you would do is install integral insulation in the empty cores of your CMU wall system, for example, instead of installing continuous insulation on the exterior or on the interior of the wall system. So that is a trade-off available to you on that one. There are some criteria, and rather than read the criteria to you, you can read these. But there's 3 criteria on the type of CMU, as far as the testing goes with that, how much can be grouted, the distance, the 32-inch on center or less vertically from a grout standpoint. So there is a list of criteria on that. In hotter climates, so climate zones between 3A, which is they can call the below warm humid line, no insulation is required for the mass walls, so you don't really have to worry about insulating the mass walls. And integral insulation is also not required for those particular mass wall systems. If we look at standard frame walls for commercial buildings, we have our option of either wood or metal frame walls. And in some cases, we only install insulation in the cavity. And in some cases, we have to both install insulation and in the cavity and also continuous insulation. Typically, this is only going to occur in metal framed wall systems. Wood frame wall systems, except in Climate Zone 8, will only be required to have an R13 insulation, whereas in metal frame wall system, starting with 5 and Marine 4, will need both an R13 installed between framing and then an R3.8 continuous insulation. So there will be a little higher requirements for metal frame wall systems in colder climates. Warmer climates, though, an R13 will be pretty much required straight across the board. We talked a little bit about metal building walls, and again, we talked about installing R13 insulation perpendicular to the girts, and this is compressed by the metal skin. Now, this is all that's required in climate zones 1 through 4 except marine, but in colder climates, we have to install R13 insulation installed perpendicular to the girts, and then an additional R13 insulation installed within the framing cavity, so parallel to the girts. So the first R13 insulation acts as a thermal break. The second R13 insulation provides that extra R value that you need for metal buildings. So again, metal buildings will have additional requirements versus a wood frame or a standard metal frame or steel frame type of building. Below-grade walls. A below-grade wall is a basement or first-story wall that is greater than or equal to 85% below grade. From a code standpoint, and this is only really going to apply in very cold climates, climate zone 7 and 8, you will have to install insulation down 10 feet from the finished grade or to the level of the floor, whichever is less. So if your floor level is at 8 feet below grade, the insulation would end at that floor level. The insulation is also, by code, supposed to be installed continuously. There's a CI by that in the table. So the insulation would be continuous insulation installed from the grade level down 10 feet or to the floor, whichever is less. And again, that is only in climate zone 7 and 8. All the other climate zones are exempted under Chapter 5 from this requirement. For floors over outside air, we have a couple of different options. One, we have a floor framed by joist or framing, which might be a small office type of complex, where it would look more like a house, or a mass floor. As is shown in this picture, this floor is over a parking garage. The mass floor system, the code gives you an option of installing the insulation, a continuous insulation, and again, I guess that's not really an option. It basically says you have to do it that way. Whereas the joist or framed type of floor system, the code basically says to install the insulation between the framing, which is where you would typically find insulation in that type of floor system. In most cases, the requirements for mass systems starting in climate zone 5 is going to be an R5 continuous insulation. When you get up in the colder climates, climate zones 4 through 6, the requirement will be an R10 continuous insulation, and then the climate zone 7 and 8 about an R15 continuous insulation. For floors, for joist or framed type of floors, it was going to be in the hotter climates, no requirements, R19 and then R30 in the colder climates. The mass floor also gives you what they consider mass floor, materials weighing 35 pounds per square foot or 25 pounds per square feet of material weight is less than or equal to 120 pounds per cubic feet. So that will be the definition of a mass floor. Slab-on-grade, heated slab-on-grade has always been very difficult to insulate in commercial buildings, and there's been problems with getting the insulation put in correctly and then protecting that insulation for a lot of commercial types of constructors. So from a code standpoint, they have basically eliminated the need to insulate an unheated slab except in climate zone 8. So climate zone 8 is a very cold climate, and in that case you'll have to insulate an R10 insulation. So from an IECC standpoint, there's no need to insulate. There maybe needs to insulate from a freeze protection standpoint that will be up to other types of building codes, but not the IECC. But if you have a heated slab, you will always be required to insulate your heated slab. So a heated slab may be a slab with radiant coils in it. It could be actually a slab with ductwork running through that is uninsulated. Those would all be considered a heated slab, and in that case, even in the hottest climate, climate zone 1, you'll be required to insulate to an R7.5. Colder climates will require higher insulation levels starting from climate zone 6 to an R10. So be aware of what's going in the slab, but again, this will be some relief for a lot of the climates that were previously insulating their unheated slabs. They will no longer have to do that underneath the IECC. Opaque doors. Opaque doors, prescriptively, there really were not a lot of requirements in the 2003 IECC other than thermal requirements, saying it had to have a U-factor, basically based on the U-factor of the glazing assembly within that building or for this particular climate zone. An opaque door is a door having less than 50% glass, and it includes two categories in the IECC, either a swinging door or a roll-up or sliding doors. In both cases, you have to meet the U-factor requirements. The U-factor requirements for swinging doors are a 0.70 all the way through except for climate zone 8, and then it's a 0.50. For roll-up doors, so you can have several roll-up doors in a building. It does not count against your glass percentage. So in climate zones 1 through 5, the requirement there is only a U-factor of 1.45, which is not a very efficient door. But in climate zones 6 through 8, the U-factor in that case will be a U of 0.50. So there will have to be some insulation put into the roll-up door within the commercial building, again, using this particular method of compliance with the energy code. You can have as many roll-up or swinging doors as you want to in your building. They just have to meet the U-factor requirement. One of the major changes within the IECC was the new glazing tables, and how glazing is actually handled underneath the code. There were a lot of categories that were added to the tables that reflect different types of site-built products, and this was actually a fairly large bone of contention as this was put in front of the Code Development Committee, and there was a lot of discussion about this particular table. But the way this table ended up right now is you have, again, on the vertical axis, the different types of window products, and on the horizontal axis, the different climate zones. So every climate zone will have a different U-factor requirement based on the type of building window assembly. Again, you're limited to 40% of the maximum above grade wall area, and so that's anything above and beyond 40 will have to use a different compliance approach. The first category under U-factors will be framing materials other than metal with or without metal reinforcement or cladding, and these are typically manufactured products. And the U-factors will range from a 1.2 down to a 0.35. So in colder climates, starting with climate zone 5 and marine 4, typically this is going to indicate a low E vinyl frame window for this type of product. For metal framing with or without thermal break, there's 3 separate categories that are now provided in the code. There's curtain wall, storefront, and then entrance door U-factors. And each one of these will have a slightly different U-factor requirement based on the capability of the manufacturer to be able to produce products that actually comply with the code. And we'll talk in more detail on exactly what these are in the next few slides. The table also gives you requirements for solar heat gain coefficients, which has been in the 2003 and 2000 IECC. And it essentially says that in hot climates like climate zone 1, 2, and 3, the U-factor requirement, or the SHGC requirements rather, are now down to a 0.25 SHGC with buildings with no overhangs. The code also gives you credit for an overhang and a projection factor, or a PF, and we'll talk a little bit about that later. Essentially, in certain climates, starting from the climate zone 4, except marine, you will be able to get rid of an SHGC requirement if you have an overhang that has a projection factor greater than 0.25. So you'll be able to substitute a overhang for a low SHGC window. Skylights will also be ramped in the code. From a skylight factor, you have 2 options, either glass skylights or plastic skylights. Each will have a U-factor requirement. Each will have a solar heat gain coefficient requirement. The solar heat gain coefficient requirement was not in the 2003 IECC, so this is something new with the 2006 IECC. Now we've kind of gone through the table, and we'll take a look at each one of these a little bit from an individual standpoint. Talked about glass percentage. Again, we're allowed up to 40% of the maximum of above grade wall. And I do again want to reiterate the slight modification in the code that could have some major implications in the fact that a wall between a conditioned space and unconditioned space can now count toward your above grade wall area. Under the 2006 code and the 2003 code, it could not. Actually, you had to insulate it, it had to meet the requirement, but you couldn't count that square footage. So that can be counted right now in addition to any walls between conditioned space and the grade outdoors. When you're looking at your wall area, the wall area is actually from the floor assembly all the way up to the roof ceiling assembly, and includes between floor walls. They have to be insulated, but you can count them in your square footage for your glass area. It also includes walls that are greater than 15% above grade. So essentially, any wall that surrounds conditioned space is counted toward your gross exterior wall area. Your total fenestration area, while the code doesn't explicitly call it out as your rough opening, that's not called out now in the code, but the intent is still the same. It includes frame and glazing, but it does not include opaque door area, and that's an important distinction to realize. So basically, you add up all of your glass area, you add up all of your gross exterior wall area that includes opaque wall, it includes doors, and it also includes all your fenestration. And that's your gross wall area. You divide that by the total fenestration area, and that becomes your glazing percentage. So now that we have our fenestration U-factor kind of figured out, we'll take a look at some of the fenestration U-factor requirements for different types of windows. First one we'll look at is framing materials other than metal with or without metal reinforcement or cladding. And this includes vinyl and wood frame products and typically manufactured products. So on the example shown on the right-hand side, the office building, small office building, you can see vinyl framed windows being used in this. And this is typical in a lot of small medical offices, a lot of small just small office buildings and small residential or low-rise commercial construction of fairly small square footage. From this standpoint, the U-factors on here, again, are a little bit easier to meet, and really you get down into the low E window requirements after about climate zone 5, where the requirement goes down to 0.35 U-factor. Site-built products have always been kind of a problem from a documentation standpoint. Site-built products have to be rated by the National Fenestration Rating Council, which is not, sometimes it's hard to find the NFRC rating on these particular products, and there's never really been a clear distinction between the different types of site-built window products. The new code actually does try to split the differences on here. The first one is defining what a curtain wall is. And by definition, if you get into Chapter 2 of the IECC, you'll see the curtain wall is fenestration products used to create an external non-load-bearing wall that is designed to separate the exterior and interior environments. So the window, the round window, the circular window shown in the picture would be considered a curtain wall product. And again, the requirements for that are going to range from a U-factor of climate zone 1 of 1.2 down to a 0.45, and that is the window and the framed combined U-factor on that particular window. Storefront is another very common type of glazing, very common type of site-built product. And again, this is, by definition, a non-residential system of windows, and windows mold as a composite fenestration structure that has been designed to resist heavy use and possible abuse and provide a high level of resistance to window load and impact from wind-borne debris. So storefront glazing has to comply with the IECC. The storefront glazing and curtain wall U-factors will be identical from a code standpoint, and again will range from 1.2 to 0.45. But this product is very common out on the market right now. As far as the types of strip shopping centers that are going in, you see quite a bit of storefront being installed right now. Again, this will either have to be NFRC rated or use the default value. Entrance doors are another category within the IECC. From an entrance door standpoint, by definition, this is fenestration products used for ingress, egress, or access to non-residential buildings, including but not limited to exterior entrances that utilize latching hardware, automatic closers, and contain over 50% glass specifically designed to withstand heavy use and possible abuse. So the example shown in the left-hand column would be considered an entrance door. And typically the U-factors for these are going to be less efficient than with curtain wall and storefront just because of the way that these doors have to be manufactured and the frame types and things like that used in these door systems. So the efficiency levels will actually be range from 1.2 down to a 0.80 U-factor. So it's a less efficient product, but again, there's manufacturing constraints on these as far as what types of efficiencies you can actually get out of these types of products. The last category is kind of the catch-all ones, those that do not fall underneath the curtain wall, storefront, or entrance door. Then it's going to be metal framing with or without thermal break. It includes operable windows, fixed windows, and non-entrance doors. So if your product does not fall underneath curtain wall, storefront, and entrance, then it falls underneath this category. And from this standpoint, again, the requirements will range from about a U-factor of 1.2 in a hot climate down to 0.50 in a fairly cold climate. This has not changed since the 2003 IECC. Essentially, all window products are required to be rated in accordance with NFRC 100, and it's either rated by NFRC 100 or you can use a default table that's contained in Chapter 1 of the IECC. But the rating will be, you'll be able to rate U-factor, and there's also going to be a rating for solar heat gain coefficient that we'll see is also a requirement as we get into this. So essentially, it either has to be rated or you use the NFRC default value on table 102.1.3 per N1. Looking at what the table looks like in Chapter 1 of the code, you have different frame types, and then you have either single pane or double pane and that will give you the default U-factor for the particular product. In some climate zones, this table will actually be helpful, and if you can use it to comply with the IECC. In colder climate zones, so the best case scenario will be a U-factor of 0.55, which will not get you into compliance in certain climate zones, especially based on the type of window product you're trying to rate. So this is an option available to you, but it's always best to use manufacturer's rated NFRC values to actually get you through the compliance process. Solar heat gain coefficient is the next requirement within the IECC. And you have a few different options on this. One is you can either use an NFRC 200 rated product, or you can use the default value to meet the requirement. Solar heat gain coefficient, or SHGC, is the ratio of the solar heat gain entering the space to the fenestration assembly to the incident solar radiation. Essentially, that means how much solar gain is blocked by that window and either reflected out or absorbed and then re-radiated to the outside. So the goal is to keep solar gain out of the particular building. To give you an example of what some of the SHGC values are, the MGM Grand, for example, has an SHGC of about 0.14, whereas Mandalay Bay will have an SHGC of about 0.12. So the 0.12 means that it blocks 88% of the solar radiation out of that particular building. The window on the lower right-hand corner, we can actually look at the default table to determine what the requirement is going to be for that particular window. So the default table for a tinted window that is also double glazed will give us an SHGC value of 0.6, which is probably not what that window is rated at. But this is an option available to you to get through the code if you do not know the NFRC 200 rated value on that particular product. Again, it's always best to use rated product, NFRC 200 rated labels for the windows. You can also get credit for an overhang. We talked about this when we were looking at the table. You have to calculate out the projection factor. Essentially, any projection factor greater than 0.25 in climate zones 4 on will eliminate the need to install, to put in a low SHGC window. So the colder climates, you can actually get by without installing a low SHGC, and there are some times you're going to want to do that. But basically, a projection factor is calculated by taking the distance, the A distance from the pane of the window to the farthest most point of the overhang, so that's your horizontal distance, dividing that by the distance from the bottom of the window to the bottommost portion of the overhang, and that becomes your projection factor, or your PF value. And that, taken into the table, will determine what the requirement will be. Skylights have a couple of different requirements now based on the type of product used for the skylight, either glass or plastic. One, you're still limited to 3% of your roof area in skylight area. This has not changed since the 2003 IECC. Then you have 2 requirements. One will be a U-factor requirement. The other will be an SHGC requirement, again, based on either a glass or plastic material type. The product can either be rated for a U-factor by NFRC 100, or there are values in the U-factor default table that can be used to rate the particular product. The default table, again, it's far right-hand side is the skylight column. Based on the frame type of the skylight, based on whether it's either single or double pane, the best value you'll be able to get is going to be a 1.05 U-factor value, which is not a very efficient skylight. So again, it's always best to use NFRC rated values for skylights whenever possible. So that ends our discussion on the thermal requirements in the IECC for the opaque surfaces and also for the glazing. And again, if you have questions, please feel free to email these in. We'll be answering all the questions at the end of this discussion. The last few topics we want to cover on this in this presentation, it deals with mandatory requirements, things you always have to do in your building, regardless of how much insulation you put in, regardless of the kind of windows you put in and how much glass you put in. That'll deal with things like air sealing, moisture controls, air leakage controls, but it's basically getting the building sealed up so that it's a lot more efficient. First requirement is going to be sealing of the building envelope. This has not changed since the 2003 IECC. It basically says to seal up any penetration in the building envelope, any seams, joints, whatever caused by penetrations, the plumbing, electrical, framing, whatever it could be. And the materials that can be used, this is just a few. One is caulking, gasketing, different types of tapes, moisture vapor permeable wrapping material. Any material that's durable and will allow for the expansion and contraction of different products that it might be attached to so it doesn't fail will work. But again, you're looking for a durable product on here, not something that's going to be that'll fail after a short period of time. So again, the first requirement of this is sealing at the building envelope. A couple of examples, metal building, you can see the framing extending out of the roof system and the foam. The foam that's shown in there is an example of how that would be air sealed. The sealing around windows, as in the bottom picture shows, is a requirement by code. Sealing around doors, but again, any penetration, anytime you can see daylight, it should be sealed up. Also, looking at an air leakage standpoint, the other requirement that was in the 2003 IECC is the requirement that exhaust openings and vents integral to the building envelope have some type of damper system put on it to be able to shut when that damper is not being used, or the vent is not being used. If you have a building greater than or equal to 3 stories in height, you need a Class 1 motorized rated or leakage rated damper. That is a requirement for a higher story building, but if you have a low-rise commercial building, which is pretty typical, and a low-rise in this case is defined less than 3 stories in height, a gravity or non-motorized damper is allowed. So the pictures on the left-hand side of the slide show reaction relief dampers, the inside view and also the exterior view of a relief damper, and those would be required, those openings would be required to have gravity dampers on them because this building is less than 3 stories in height. Another air leakage requirement that was in the 2003 IECC is the requirement for loading dock weather seals. This is only required if the loading dock is a conditioned space. So if you have no space conditioning equipment in the loading dock, you do not need to install the weather seals. But if you're, again, conditioning the loading dock, the weather seals will allow you to back a trailer up to that. The weather seal goes around the back end of the trailer and drastically reduces the infiltration into and out of that particular part of the loading dock. There is no requirement for specification for loading dock weather seals, by the way, but the goal is to restrict infiltration. Another requirement that was in the 2003 IECC is a requirement for vestibules. And essentially, a vestibule has to be placed on the exterior doors leading from a conditioned space greater than or equal to 3,000 square feet. Not a conditioned building, but a conditioned space. So in the diagram on the right-hand side, the exterior doors leading out to conditioned space greater than or equal to 3,000 square feet would need a vestibule. The vestibule has to have self-closing doors going into and out of the vestibule. So we have self-closing doors here and self-closing doors going out of the vestibule. The doors have to be designed and the vestibule has to be deep enough so that the doors do not have to open and close at the same time to be able to pass through the vestibule. Otherwise, it defeats the purpose of creating an airlock. The other exemptions on this, buildings in climate zones 1 and 2. So hotter climate zones are not required to have vestibules. Doors leading from guest room or dwelling units, and again, a high-rise residential building is considered a commercial building. So in this case, though, doors leading from a guest room, if you had a very large guest room or a very large dwelling unit that was configured so that you had one space with the door leading off of it that was greater than 3,000 square feet, that would be exempted. And then doors used primarily for vehicular movement, material handling, and adjacent personnel doors. So this is kind of the primary requirements for the vestibules. You can get on the DOE website because the vestibule webcast that was done last year should be on there, and that will give you a lot more information as far as vestibules go. The next requirement is for recessed luminaires installed in the building envelope. So recessed can lights that are becoming very, very common in a lot of commercial construction, and these are only if they're installed in the building envelope, not if they're installed in a drop ceiling, which you typically see a lot installed in the drop ceiling. So again, the drop ceiling cannot be considered part of the building envelope. So this does not apply to recessed cans in a drop ceiling. But if it's installed in the building envelope, you have a few different options for meeting the requirement. One is you want to put in a can light that can have contact with insulation. That's the Type IC insulation contact can light. So you want to make sure that you have pretty continuous insulation in your roof ceiling assembly. And then you want to put in a can light that's sealed up or fairly sealed up by code so you can reduce the infiltration losses out through that can light. So you have three different options available to you to meet the code requirement. Option number one is Type IC rated with no penetrations in the fixture and sealed or gasketed to prevent air leakage. So the IC rating will give you the insulation contact, and the no penetrations reduces the infiltration. The next is Type IC or non-IC rated, installed in a sealed box with greater than or equal to 1/2 inch clearance from combustible material and greater than or equal to 3 inches from insulation. This is typically the least desirable way of installing the cans from a cost standpoint and things like that, because essentially you're taking a fixture that does not comply with the code and you're building a box, a gypsum board box or something over the top of that to seal it up from the building, from the attic area. Last but not least is the Type IC rated and tested in accordance with ASTM E283 to allow less than or equal to 2 CFM of air movement. So that is an IC rated airtight can. This is probably going to be the most typical can that you'll be able to find on the market right now. We use a lot of residential construction. But again, if this is installed in a building envelope, then it will have to also apply to commercial construction. So that does it from an air leakage standpoint. We'll take a look at one more requirement right now, and that will be on moisture control. And essentially the requirement is that any unvented framed cavities, this is going to be a wall system, roof ceiling assembly system, or floor system, has to have a vapor retarder installed on the warm and winter side of the installation. And there are requirements, or there are exemptions rather, in certain climate zones. For example, climate zones 1 through 3 are exempted from this requirement. Also, where moisture or it's freezing will not damage the materials. And option 3, where other approved means to avoid condensation are provided. Approved means approved by the building official. So if you have a method for reducing moisture in a particular wall system or floor or roof ceiling assembly, if it's approved by the building official, you can go ahead and install it. Well, that wraps it up for the building envelope requirements. Now I'll send this back to Pam. Thanks.
Again, if you have questions and comments, there's 2 avenues to do that. I gave you the tech support email that you can take down. And then if you forget that or you don't write it down, if you go out to our website, there is a help desk online electronic form that you can go to, fill out your name, and submit your question that way, and they come right in, and we will answer them. That ends this portion. Thank you for attending our session today.
This ends the training video. If you would like to take the test to receive AIA credit and or print a certificate of completion, please write down the URL shown on the screen. You will need to type this URL into your internet browser. Thank you.